Hello everyone, let's solve this problem. LeetCode number 3, the longest substring without repeating characters. Okay, so for this question, let's see. Given a string S, find the length of the longest substring without repeating the characters. So in this example, let's see, the input is the ABC, ABC, BB. So the longest substring without a repeating character is 3. So we can see here ABC, or we can do ABC here. So, and this is another example is BBBBB, and then the longest substring is gonna be 1. Okay, this one is PWWKEW. So the longest one should be this one, right? Okay. So for this problem, so what we do for this problem? We will do okay. So first, we will consider this problem using the brute force algorithm. Okay, let's give an example. Let's give example. Let's do this example. Okay, here's the example. So first we can use the brute force algorithm, and here is the I, and here is J. So we can actually generate generate all the substrings. Okay, so start from 0, we can do 0, 1, 0, 2, 0, 3, 0, 4, and until 0, 9. And start from 1 is a 1, 2, 1, 3, 1, 4, 1, 5. Okay, so yeah, in this way. So we kind of like just generate all the substrings. Okay, so for the time complexity, for this problem is gonna be O(n) cube. Okay, also we can do it O(n) square, so it depends how you experiment. Okay, so the space complexity for this problem is O(n). So because we just checked the repeating character using a Hashmap, so that's why it's O(n). Okay, so we can also use another algorithm. Okay, so we can use the Hashmap. Here is the example. 1 second, let me give an example. Okay, so we can also use the Hashmap. So the Hashmap actually we record the frequency. So like the latest one we visit about our characters. Okay, so from for this problem, let's start from here. Okay, let's start from here. Here is the left pointer. And also, we have another pointer is the right pointer. Okay, so we have 2 pointers. So we have a range. We have a range R minus. Oh, we have a range is start from L to R. Okay, this is our range. Okay, so how to compute the length of this substring? So the length of this substring actually is the length of this substring is gonna be R minus L plus 1. Okay, after we know all this, so what do we do? So first we check the character if it exists in Hashmap or not. Okay, so let's start a Hashmap. Let's think maybe the Hashmap. Okay, let's do this way. This Hashmap. Okay, here is the length. Okay, we are just trying to. Okay, let's do this step. So let me just copy paste this. Okay, so first we check the character exists in Hashmap or not. So in this case, we check the R if exists in the Hashmap or no. So in this case, R equals to 0. So A is not in the Hashmap. So we push the A to the Hashmap. Here is A, and the index is 0, and then R advance. Okay, so R one step ahead. Okay, so R equals to 1 now. So we check the B if in the hash map or not. So in this case, B is not in the hash map. So we put B in the hash map. Okay. And then we do R plus plus is C, right? So the C is not in the hash map too. We put C in the hash map. C in the hash map, okay? And then we do R plus plus. So we check here is A. So we check A if A is in the hash map or not. Yes, we do. The A is in the hash map. After we do, if this character A exists in hash map, then we update the left. So the left will be, so when we check the hash map, A is here, right? So the index of A is 0. So it's 0. So we update L to here, okay? To here. Okay, this is what we update. So because when we update the L, it's greater than, now L is equals to 1. It was 0, right? So it's greater than that. So we just updated the L equals to 1. And then after we update the left, we update the map. Because the A, it was 0, the index, but now the A index is 3. So this is the most frequency one. So here we update the map, and then we update the length. So the length, it was, okay, so the length, actually start the beginning. So when we put A, so initially length is 0, and then we put we push the A to the map is 1, and okay, and then we put B there, and then it's 2, and we put C is 3. Okay, and then we can check R minus left plus 1. So it's 3 minus 1 is 2, 2 plus 1 is 3. So it's still 3. So we don't have to update this. Okay, and then right plus plus. And then we check the A if exists in the hash map. In this problem, yes. So what we do, we update left. So how do we update the left? So we just check. So we just check the A is here, right? So the index of A is 3. So 3 plus 1 is 4. So 4 is greater than 1. So we update. Okay, so left is here. So we update the left is here. And then we update the map because here A, right now A is in the index 4. So we put just here is 4. Okay. And then we update the length. The length is R minus 1 plus 1 is 0 plus 1 is equals to 1. 1 is smaller than the current 3. That's why we don't update the length. Here we still have the longest length is 3. So, and then right plus plus. After we write plus plus, we check B if in the hash map or not. So in this case, B is already in the hash map, then we update left. So what we do, we check the B, the index is 1. So B index is 1 and plus 1. So it's going to be 2. And the 2 is smaller than the L. So in this case, we don't update L because the one in here is already there, so we don't have to update the L equals 4 is greater, so we don't update that. So and then we update the map. So let's check the B. The B, it was at 1, index 1, but now we update at 5. Here's 5. And then what we do, the length. Let's talk about the length. So r minus 1 plus r minus L plus 1 is 5 minus 4 plus 1 is 2. So still we don't have to update it because we have the longest one currently is 3. Okay, and then write plus plus. After we do the write plus plus, we check the C if C if C in the map or not. Yes, it's in the map. So what we do, we update the left. So we check the previous C is 2. So the left are gonna be 2 plus 1 is 3, but it's smaller than this one, so we don't have to update the left. And then we just update the map. The map right now is the C in the map is 2, but now our C in the index is 6, so we just update the 6. After we update the 6, we update the length. The length will be r minus left. It's gonna be 2. 2 plus 1 is 3. 3 is 3, so we don't have to update here. And r plus plus. R plus plus at 7, and then check D if in the map or not. So D is not in the hash map. So what we do, we D and put a 7 here. Okay, so we just do this. We update the map, and then we update the length. Okay, so the length gonna be 7 minus 4 is 3. 3 plus 1 is 4. Okay, so it's 4. Okay, so we update here. It's 4. Okay, and then write plus plus and write plus plus. Write equals to 8 now, and then we check the B if in the map or not. So in this case, B is in the map. The previous B, it was at 5. 5 plus 1 is 6. And 6, this left is greater than the current 4. So now we update left to the 6. Okay, so yeah. And then what we do, we update the left and we update the map. We update B, the index of B here is gonna be 8. Okay, after we update the map, we update the length. The length is gonna be 8 minus 6 plus 1 is going to be 3. So 3 is smaller than the current greatest one is 4, so we don't have to update the length, the longest. Okay, so and then we R plus plus. When we do R plus plus, and then we check the A if A in the hash map. If A in the hash map, then we updated the left, and then we know the previous A is in the index 4, so 4 plus 1 is going to be 5, right? So, but the 5 is smaller than the current one, so we don't have to update the L, the left. And then we update the map. So the A in the index of none, so we update here. And then we update the length. Length is going to be 9 minus 3 plus minus 6 plus 1 is going to be 4. So 4 is equals to the longest one, 4. So we don't have to update it more. And then what we do, we R plus plus. Okay, but now R is greater than the length of the string. So in this way, we just stop. Okay, so yeah, this basically the algorithm, and then we return the length. We return the 4 here for this problem, for this question. Okay, let's start coding. Let's start the coding. So for this problem, first what we do, we new a hash map. The name is map. Character, right? Yes. Integer. Okay. And then we initial the left equals to 0, the right equals to 0 too. Okay. And then what we do, we compute the n equals to length. Okay, and then the length gonna be 0. Okay, so we do while right smaller than n. So what we do, we check if the map, dot contain, if the map contain the k or not. So what we do, we just do this way. Char at right. Okay, char at right. And then we update the left. So we are going to get the maximum of the map dot get the char at right plus 1. Okay, and then left. Let me see if it's right. So here we have this, here we have this, here we have this. We have this, yes. Yeah, it should be right. Let me double check. Okay, left equals to max map dot get start right. Here actually is wrong because we get, see, this is a char at right, so we get the character, and then we get the character, we check if in the map or not. So here we don't have this one. Okay, let's check the code. So first we new and have a map. So that's a hash map. Okay, so that's a character and a integer. Okay, the integer is the index and the character is the character we get it from the string. Okay, and then the left equals to 0, the right equals to 0. N is actually the length of the string. Okay, and then length initially is 0, and then we check if while the right smaller than n, smaller than the string of length, and then what we do, we just do check if the right explorer, the right pointer in the character in this string, the character in the right pointer. So check that character if exists in the map, in the hash map. Okay, so if we can turn that map, then we compare the left So the previous one, the left the character plus 1, and the current left. If smaller than that, then we update we just keep the left. If greater than that, then we just take this one. So that's why here is a max. Okay, and then we push the right to the map. Okay, I just showed you guys, and then we calculated the length. The length is gonna be, this is the length. Okay, and then we trying to update the length, and then write advance. Okay, at the ending, after we out this while loop, we just simply return the length. Okay, this is the problem. Let's run the code. Oh, here is not Hashmap character. Okay, here goes some problem. Character. Okay, sorry about that. Here it should be character. Yeah, it should be like this. Character. Okay. Okay, it's accept. Okay, let's submit the code. Okay, it's faster than 95.76% for Java online submissions. Okay, do we talk about the time complexity now? Yeah, so the time complexity for this problem is gonna be ON. The space complexity is gonna be ON as well, but we can also think this way. So the space complexity will be O1. Why? Because so we know the time complexity, right? Because we just iterate a single one character from beginning to the end, and then the space complexity is going to be OM. So the N is the size of the hash map. But in this problem, because the map can contain at most 26 alphabet. Okay, so we can say the space complexity for this problem actually is 1. So it won't increase more than the size of data. So we just say, the space complexity for this problem is gonna be 1. Okay, thank you for watching. I'll see you next time.